Hey, welcome to Nutshell Maths, where we do maths in a nutshell. Today, we are doing difficult questions. Uh, this is a new series, and in this series, I'll be doing a difficult question that I've never seen before. Uh, I'm not sure what the answer is. I haven't looked at this question. I haven't tried it. I've got the answers ready to go to at the end, but I haven't looked at them. So I will likely make some mistakes. Hopefully not, but I might make some mistakes. I might go down the wrong path. Who knows where we'll end up. But the idea is that you get to watch me try and solve a difficult maths problem. And hopefully you'll learn something along the way of how to go about it, some possible paths you could take, or just the process of trying something that's hard and new. This is a level 3 calculus integration question. It is an excellence question. I've got my little timer here, I've got my calculator here. My timer is just to show that it is live, one take. I won't be doing it again. If I get it wrong, I'll probably still show you just to see if if you learn something from it. But yeah, we'll get ready to crack into it. As with always, all of these videos, I highly recommend you pause it. Right, pause it here. Try the question yourself. You should give it a good proper whack. Spend at least 15 minutes trying the question, and then press play and see how you go compared to me. Let's get into it. Right, start the timer. Let's go. So the mean value of a function from from x equals a to x equals b is given by this big formula here. We've got the integral between a and b of f of x all over b over a. Cool. Sorry, b minus a. Find the mean value of y equals sine squared x. So I'm going to have to probably integrate this between here and here. Part of the graph shown below. That's nice of them. Cool. So we want to find the mean value. Okay. So the mean value includes this piece here. The area between a and b. And in this case, this is a and this is b. Right? So this is the blue part. Right. So we're going to need to integrate between a and b, 0 and pi, of the function sine squared x dx, and then later on divide it by, let's put it in red, b minus a. Okay, I'm not going to deal with that right now. B minus a would be, in this case, pi minus 0, so divide by pi. So that I'm thinking that should hopefully cause some cancelling there. But let's see, the integral of sine squared x. Okay, I know I can't just integrate that straight out the gate. That's too hard for me. But when I see like a sine squared or a cos squared, I start thinking formula sheet. So I've got my formula sheet here. Let's see if I can spot a good formula here. Right, sine squared, sine squared. This one has a sine squared, but it's just going to turn into cos squared. Sine squared. Here we go. This helps, right? So this, look here, this has a sine squared, but it's got a cos squared too. We would end up with the same problem. This isn't helpful. This has a sine squared, and it's all the other parts is cos 2a and 1. I know I can muck around with that and be okay. There's not really any other formula here. I could probably, technically I could do this, I think, with a and b being the same. I'd end up with this, but that is literally the same as this. So let's do this. Right? I'm going to write it out to the side a little bit. Might put some dotted lines and just write this formula. Cos 2a equals 1 minus 2 sine squared a. Right. So let's have a look. We've got sine squared a. Let's rearrange this whole formula. So we get cos 2a minus 1 all over minus 2 equals sine squared a. I'm going to make this a bit nicer. Let's make it minus cos 2a over 2 plus a half equals sine squared a. Yeah, nice. And so I can rewrite this, replace the a with x's, and we've got this integral here. So the integral between 0 and pi is now going to be, instead of being of sine squared x, it's going to be of this. Minus cos 2x over 2. I can do that, plus a half dx. And I'm going to do this all kind of separately. So the integral of this first part, still haven't memorized my integrals. So the integral of cos becomes sine. So if it's minus cos, it'll become minus sine. So this is going to be minus sine 2x over 2. But then we're going to divide by the coefficient of this linear function inside. So divide by 2, which would be times n by 4 on the bottom. Cool beans. Plus a half x. Don't need the plus c because it's a definite integral. 0 pi. Cool, just double checking everything seems okay. Nicely done. Now I'm going to sub in pi and sub in 0. This is where our calculator will be handy. So I kind of like to do this, where I'll put in my pi piece first. So you can see my calculator here. Sine 2 pi. 0. Double check my calculator in radians. Good. So that's going to be 0, which makes that whole piece 0, which makes that all that 0. Cool. Don't care about it. 0. Plus 0. That's easy. Minus. So let's double check this. Sine of 0 is also 0. Nicely done. This is 0. And 0 here. I feel like something's gone a bit fishy here. I don't like where we've ended up. This whole thing is 0. Which doesn't seem right. What have we done wrong here? Pi of the graph is y equals sine squared. It must be in this proof here. Let's double check my formula sheet. Cos 2a is 1 minus 2 sine squared a. I'm happy with that. Sine squared x. I'm looking over here now. Oh, I've been silly. I got carried away here. Look, I told you I was going to make some mistakes. I've spotted it here. This pi goes into here, and I was thinking so much of this 0 stuff that I just got carried away with 0. Silly man. Right, we're back on track. This becomes, oopsies, pi by 2 when I sub in here, and this is going to be minus 0. That makes me much happier, right? Because now it's a pi by 2. And remember I said before, we're going to be dividing by pi and hopefully something cancels. Nice. Right, let's have a look here. So when I get to these natural lulls in these questions, I reread the question every time. So I'm at like a natural lull, or I've hit a point equals something. Let's reread this question again. So the mean value is this top part, which we just did, the integral of that function, all divided by b minus a. In this case, b minus a will equal, I might even just write it here, b minus a will equal pi minus 0, which will equal just pi. Nicely done. So let's do a therefore the mean value is pi by 2 all divided by pi, which is the same as 1/2. I'm pretty happy with that. I don't think anything's wrong. Stuff is cancelled, so it makes me feel good about the question. Yeah, done. Right, 7 minutes 45 for an excellence question. I think it's a nice excellence. Let's double check we got it right. Here's the answer scheme over here. Final answer, half. I know I'm correct, so that makes me feel good. They showed all that, but I couldn't be bothered. I just double checked stuff on the calculator, but that was my that's where I made the mistake too, right? So I should be a little bit more careful around that. Yeah, cool. Nicely done. Half correct. Happy. Right, so there we go. We have tackled an excellence question. 7 minutes 45. This was like a sheep in wolf's clothing, right? It looked gnarlier than it was, right? I've never seen this mean value thing before. It looked real scary and gross. sine squared, mean of this, divide by b over a, so many letters, but all we did was one reasonably straightforward integration and then divide by a number. Right? I think this is a soft or a nice excellence that they've given you, to be like, are you scared of maths? If you're not scared, you should be fine with this. Cool, and with that we're done. If you've got any questions, post them down below. If you're confused, if you've spotted a mistake, post it down below, please. If you've got a difficult question you would like me to try, please post it below or send me a link somehow. And if I like the look of it, I won't try it, but I'll try it on video, and we'll see how we go. Thank you guys for watching, and enjoy.